3/7 solving system equations using Cramer's rule, and we're not going to do that. We're actually just going to focus on determinants in this lesson. Should be a short video. We're just going to focus on determinants. Cramer's rule, I'll probably talk about it for a second, but it's not the best way of doing anything, so we're going to skip it. Anyway, so let's talk about what a determinant is. It's a special number all square matrices have. So every square matrix has a determinant of a 2 by 2. It's called whatever. That part doesn't matter. The key part is what a determinant, it's a special number. All square matrices have. We use that number to solve lots of things. Square matrices have. So let's say I give you a basic matrix here. A, B, C, D. If I want you to find the determinant of it, I could say find a determinant of it like this. Or I could write an absolute value. A, B, C, D. So if you see it in that form, that also just means find a determinant. Now how do we do it? Well, for a 2 by 2, all we do is downward diagonal minus upward diagonal. So it's going to be kind of like this. So we're going to do AD minus BC. And that's how I find a determinant of a 2 by 2. That's the shortcut way of finding a determinant of a 2 by 2. There's actually a more proper way I might get into later. But if you want to find a determinant of a 2 by 2, you want to find that special number that all square matrices have, you just do downward diagonal minus upward diagonal. So let's do a quick example, then we'll do a few more. Alright, so if I gave you that, the determinant's going to be 8, 2 times 4, minus 3, or 5. And that's the determinant of a 2 by 2. Let's do a few more quick examples. Let's do that. We'll also have, I guess, 1C here. 5, 3, 2, 1, 6. It's meant to do a straight line. Anyway, right, so determinant of this, down minus up. So negative 6 times 8 minus negative 7 times 10. I get negative 48 plus 70, also known as 22. Over here, right, down minus up, I get negative 28 minus 45. 50 plus 30, 80 minus 7. So about 72, negative 72. Again, that's all it is for a 2 by 2 determinant. That's all it is. Right here, down minus up, 3 times 2 minus 1 times 6. In this case, I get 6 minus 6, which is 0. And that's actually a special result. Special result. So actually legible, kind of. So that's a special result. It means you have no inverse, and we'll talk about that more in the next video. But keep that in mind. It says no inverse. So that matrix has no inverse. Again, we'll talk more about that later. So that's how you do determinant of a 2 by 2. Just down minus up, down diagonal minus up diagonal. How about a 3 by 3 and higher determinants? Well, a couple things. A, B, C, D, E, F, G, H, I. So first, before I start this, in our book and in our school, we don't give determinant 3 by 3 by hand anymore. So I'm actually just using the calculator. We'll do an example of that in a second. Should I do determinant on the calculator? The way you're supposed to do it, the proper way of doing it is, it's just kind of a convoluted, but what it is you pick a row or column, any row or column, and then they all have a cosine chart. A sine chart, we call that. So plus minus plus, this would be minus plus minus, plus minus plus. What you do is you pick a row or a column, anything you want actually, you expand on it. So like in this case, let's say I picked the top row, and let's say I picked A. What you do is you cancel out that column and that row. If you look at what's left over, you have A times this little small 2 by 2. Then you can do the same thing to the next one. So I'm going to circle my B, I'll cancel out its row and column. if you just don't look at the blue stuff, like what's left over, you have DGFI. So you have negative B times DFGI. And then finally you only fill out one row or column. You do the same thing to the last one. So circle this one, plus C. Cancel out its row and column. And you're left with the determinant of DEGH. And what you see here is all this would be do this little determinant, down minus up, times it by A. Do this little determinant, times it by negative B. Do this determinant, times it by C. And then that'll be your answer. So that's how you determine a 3 by 3, which again, I won't be asking you in this book, because our book only expects to do in the calculator in our class. So the new Common Core standards only do calculator. But that is the way you do it. And that's actually the same way you're supposed to do a 2 by 2. You're supposed to like do a little sign chart, circle, cancel out, 7 times 4, negative 4, plus negative 5 times 9. Because you circle and cancel it out. And that's where we get the down minus up thing from. So that's where it comes from. But again, for 3 by 3, we're just going to use it on our calculator. And this, by the way though, this method also works for higher derivatives. If you want to do 3 by 3, 4 by 4, 5 by 5, you all do them the same way. It's just pick a row column, expand. You do more of it in linear algebra. Anyway, after all that, let's do an example on our calculator. Here's my calculator. So the way we're going to do is like this. We're going to type this in. So I'm going to go to math. Sorry, we're going to go to matrix, second matrix. I'm going to go all the way to edit so I can type my matrices in again. This matrix is a 3 by 3. Type in all the values. -4, 6, and 2. So I just went through, typed in all my values. Now let's get out of this. I'm going to go back to my matrix. And remember how I mentioned this before, how this is where you select your matrix. There's my 3 by 3. This is where you enter in your matrix. Math is where you do all the applications. So we're going to go to math. The very first one you see there is called, it's a determinant. That's the determinant function. So you hit that, select your matrix, and get an answer, -48. And that's how you determine a 3 by 3 with your calculator. Again, what's it doing? It's doing this. It's doing the thing where it highlights a row, selects it, does a smaller determinant, but you get the answer, -48. So that's it for determinants, right? So 2 by 2, down minus up, very important. 3 by 3 and higher, just use your calculator. I mean, there's a method that does it, but we're just going to use your calculator. Let's go talk briefly about Cramer's rule. So again, we're not really going to use this, but it's something you probably should understand what it is, kind of. So Cramer's rule is a way of solving system equations. So let's say I gave you quick system 2x plus 3y equals 4, and -x plus 4y equals 5. And you want to solve this. So right now we can do elimination substitution, we can do graphing, and I'm going to show you a different way called Cramer's rule. Now Cramer's rule is really 3 components. You need to find a determinant. So let's rewrite this as like a separate matrix. So we're going to write it like this. We call this coefficient matrix. 2, 3, -1, 4, x and y, 4 and 5. So this is our coefficient matrix. So this is the coefficient of our x's, right? 2, -1. This is the coefficient of our y's, 3 and 4. And then we'll have x and y right here, and this we'll have our solutions or our answers right there. Now Cramer's rule really just say 3 things. You find a determinant of the coefficient matrix. So 2, 3, -1, 4. In this case, it'll be 8 plus 3 actually. So 12, 11. I can do math. So 11. All right, down minus up. So 2 times 4 minus 1 times -3, or 3 times -1. You get 11. And then we have to find 2 more determinants. So for our x value, that's called determinant of x. What we're going to do is we're going to switch the x column with the answer column. So it's been like this, 3 and 4. Then I'm going to switch the x column with the answer column. So instead of having x, I'm going to have 4 and 5. You can take the determinant of this, 16 minus 15, so 1. Now we're going to do the same thing for dy. So we're going to switch the y column with the answer column. So my y column is going to be 4, 5 now. and then down minus up, so 10 minus negative 4, so I get 14. And now, what's the final part of Cramer's rule? Well, very simple. If you want to find x, it's just dx over the determinant. If you want to find y, it's just dy over the determinant. So our x is going to be 1 over 11, and our dy is going to be 14 over 11. And that's the answer. That's Cramer's rule. You're like, oh, that seems kind of easy. It is. I mean, it's a little long. I think elimination will be a lot faster. Again, in this case, it's fraction, so it might help. And then when you get 3 by 3, like this would be faster for 3 by 3, except for the fact that they find determinants of 3 by 3, and it takes forever. So it's actually not that much faster. You're like, oh, let's take determinant by a calculator. But then there's an easier way to do it if you can do it by a calculator. It's like, why are you going to do this method if there's an easy way to do it? But I did want to show you Cramer's rule, so that's Cramer's rule. And that's how it works. It works the same thing for 3 by 3 and 4 by 4. You just do the same thing. You find a determinant, and then for each variable, you just switch that column with the answer column. Then you put that over the determinant, and you're good. So there's Cramer's rule.